This is the tutorial for reading a single pole double throw switch. This is the basic code for reading a single pole double throw switch, or an SPDT switch. We're going to be using a SPDT switch to select which LED to make blink. Starting off, we're going to create constants for the pins we'll be using. So switch pin will be 3, and the first LED will be 12, and the second LED will be 13. Then we're going to set the switch pin as input, so that the information is going to go from there and then into the LEDs, and then setting LED 1 and LED 2 as outputs. Then we go to void loop. In switch value is going to be the variable to hold the switch state that it's in, and since the switch only has a high or a low state, there's no way for a floating point situation, so there's no need for a pull down resistor. So that means either one LED is on or the other one is. There's never a point where they're both off. So then we're going to store the switch value using the digital read switch pin. So then we go to the code. So if switch value is equal to high, then the first LED will blink. So it's going to turn the LED 1 pin high, delay for half a second. Then it's going to turn the pin on low and then delay for a second. Else, so if it's not on high, then it's going to blink the second LED. So LED 2 pin on high, delay for half a second. LED 2 pin on low, and then delay for half a second. It's going to turn them on and off, blink them off. That's it. This is the circuit board for reading an SPDT switch. So here, this black wire grounds the SPDT switch by connecting the column through this black wire, which is grounded in this ground pin here. And then the long orange wire here connects the SPDT switch to pin 3 here. And then this short orange wire connects the switch to through the red wire to the 3.3 volts. And then, so that's going to work there. And then both LEDs are grounded since their cathodes are on this the negative column. It's connected through this black wire here to the opposite column, which is again grounded by the black wire here that goes to pin the ground pin over here. And then the red LEDs anode there's a 100 ohm resistor here, and then it's connected to pin 13 through this yellow wire here. And then similar to the yellow wire, again another 100 ohm resistor, and then this yellow wire connects to pin number 12. And this is the SPDT switch working. If we switch it, it'll switch LEDs. If we go back, this is the modified code for reading an SPDT switch. So first we're going to create constants for the pins that we'll be using. So the switch pin at pin 3, and LED 1 and LED 2 pins at 7 and 6. Then we're going to include the servo into the library, include the servo library. And then we're going to create a servo object called servo 1 to use later. We get to void setup. We're going to set the switch pins to be an input here, and then set both the LED pins to outputs. Then we're going to attach servo 1 to pin 9 on the Arduino, and then set up our serial begin monitor. Then we're going to void loop. We're going to create a local variable to store the servo's position, so in position. We're going to use that down here. And then we're going to create variables to hold the switch state. And then we're going to have the switch value use the digital read function to read the switch pin and store it as switch val. So then when we get to, since the SPDT switch only has high or low, we're going to use an if and else statement here. So if the switch val equals high, we're going to turn the LED 1 pin onto high. We're going to turn the LED on. Then we're going to delay for 250 milliseconds. Then we're going to turn it to low, so we're turning the LED off, and we're delaying for another 250 milliseconds. We're going to also print on a new line, SPDT high, LED 1 on and stepping by 4 degrees. So we're telling the servo to go to 180 degrees and stepping by 4 degrees. So if position is 0 and less than 180, then the position is going to increase by 4. And then it's going to move to the next position using servo 1 dot right position. And we're going to wait 20 milliseconds for a pause to allow it to move. So then if switch value is not equal high or if it equals low, we're going to make the second LED turn on and wait for 500 milliseconds. We're going to then turn it off by using digital light to turn it to low, and again delay for 500 milliseconds. And then we're printing on a new line, SPDT low, LED 2 on and stepping by 2 degrees, because we're telling the servo to go to 180 degrees, stepping by 2 degrees. So it's going to be a little slower than before. And then servo 1 right position is going to move to the next position, and again delay for 20 milliseconds. And so this, for the else thing, the LED 2 is going to take twice as long to blink, and the servo motor is going to take twice as long to the amount of time that the first servo motor was taking to get to 180. So those will be correlating to the time it takes. Monitor for the board working. So right now the single pole double throw switch is on high, and if we turn it to low, then it will switch. See, it takes longer. And if we go back, it'll switch again. There we go. This is the board for the modified code of reading an SPDT switch. Here's the switch, and the common pin is connected by this orange wire to digital input pin number 3. And then it's connected to 3.3 volts through this red wire here, and then this column to this orange wire that it connects to 3.3 volts. And then it is attached to ground through this black wire here, this gray wire here, into the ground column, through the black wire, and into the ground pin over here. So when the common pin is attached through the red wire to the 3.3 volts, then it will be on high, and when the common pin is attached to the ground through this gray wire, then it will be on low. Then we go to the LEDs. The LEDs are connected through the 100 ohm resistor to their digital output pin, 12, and same to the yellow LED pin 13. And their anodes are connected through the 100 ohm resistor, and their cathodes are both connected to the ground here through this ground wire right here. Then we go to the servo motor over here, and the power is connected through this red wire to the 5.5 volts. It is grounded through the black wire here, and then it is connected to digital pin number 9 through this yellow wire. So you can see it's on high right now, so the servo motor is going the fastest and the LED is blinking fast. And then if we switch it to low, then the servo motor will slow down to going by 2 degrees, and the yellow LED will blink slower. There we go.